In today's bulletin, we explore how additive manufacturing is reshaping energy, aerospace, defense, and even Formula One. From AI-powered optimization to field-ready combat repairs, and from tariff pressures to hydrogen-powered aviation, AM is proving its critical value across industries. Let's get straight into the developments. We begin in the UK, where additive manufacturing is becoming a cornerstone of fusion energy development. The UK Atomic Energy Authority has selected Additive and Kingsbury to install a Nikon SLM280 laser powder bed fusion system at its Culham facility. This move supports the production of critical components capable of withstanding the extreme environments inside fusion reactors, particularly through the use of tungsten and copper composites. For AM professionals, this represents a major step in applying high-performance alloys and design for heat strategies in clean energy systems. Now turning to Canada, where researchers at the University of Toronto have introduced a new machine learning framework called AIDED. Designed to accelerate the optimization of laser-directed energy deposition processes, AIDED uses dual ML models and a genetic algorithm to recommend ideal print parameters based on performance goals. This technology significantly reduces trial and error and allows engineers to iterate designs within hours rather than weeks. It also shows strong transferability across materials like stainless steel and nickel, making it an ideal candidate for rapid deployment in diverse industrial environments. In the field of defense, additive manufacturing has demonstrated its tactical versatility. 2 US Army soldiers deployed with Task Force Wolverine used training from the Naval Aviation School for additive manufacturing to produce custom antenna mounts for MRAP vehicles. The parts, printed in UV and heat-resistant ASA polymer, met all operational criteria, including structural integrity and emergency hatch clearance. While the material wasn't part of their initial training, their success underscores AM's adaptability in mission-critical contexts and the growing value of cross-branch AM education within the military. Across the Atlantic in Spain, AMN Technology Centre has developed the nation's first large-scale 3D printed cryogenic hydrogen tank for aviation. Produced as part of the EU's Overleaf project, the 1.5-metre tank integrates a bio-based thermoplastic liner and carbon fibre composite shell to maintain integrity at cryogenic temperatures below -250 degrees Celsius. Using robotic 3D printing and infrared-assisted heating, the project highlights a major stride toward zero-emission aviation. For AM professionals, it signals new frontiers in sustainable large-format composite printing and thermal resistance engineering. Looking skyward, Japan's Interstellar Technologies is accelerating its spaceflight capabilities through additive manufacturing. The startup is producing critical rocket components such as combustion chambers with the goal of reducing production cycles and costs. This positions Interstellar to compete with more established players like SpaceX and Blue Origin. In a rapidly evolving launch industry, AM is clearly emerging as a key enabler of nimble, cost-efficient innovation. At the upcoming Paris Air Show, aerospace giant Liebherr will spotlight several additively manufactured components, including a complex hydraulic valve for the Airbus A350 and a newly developed heat exchanger. These are not prototypes, they are flight-ready, serially produced parts. This marks a significant milestone in AM adoption for certified aircraft systems. Engineers and OEMs attending the show will have the opportunity to examine firsthand how AM is now delivering on airworthiness, efficiency, and repeatability. Meanwhile, Nano Dimension is refocusing on its core competency, additive manufacturing of electronics. After a period marked by high-profile acquisitions, the company has reaffirmed its investment in AME, a technology that uses conductive silver ink and UV-curable dielectric layers to print functional circuit boards. The process allows for rapid in-house prototyping and on-demand electronic component production, serving sectors like aerospace and defense, where speed and customizability are paramount. From technology to trade, the additive manufacturing sector is closely watching new tariff proposals in the United States. Recent models suggest a potential 20 to 30% cost increase on machines imported from Germany and China. These tariffs could reshape procurement decisions, with manufacturers weighing supply chain adjustments and considering North American alternatives. While the industry is largely in a monitoring phase, strategic sourcing and risk assessment are becoming more urgent in procurement conversations. In the high-speed world of Formula One, 3D printing has become indispensable. Teams like McLaren are leveraging AM for everything from aerodynamic prototyping to full performance structural parts. The speed and flexibility of additive manufacturing allow F1 engineers to develop and iterate new components between races, all while staying within the stringent regulatory frameworks set by the FIA. This is performance engineering at its most advanced, and additive is right at the centre. Finally, the UK is aiming for a tenfold increase in certified flying additive parts by 2030. Through its Aerospace Technology Institute, the nation has outlined a roadmap to build a fully capable end-to-end domestic supply chain. This includes everything from materials development to part qualification and serial production. For British manufacturers and design firms, this strategy offers both a challenge and an opportunity to become world leaders in aerospace-grade AM. That concludes this edition of the AM News Bulletin. Whether it's fusion energy, frontline operations, or sustainable aviation, additive manufacturing is at the core of transformative change across industries. We'll continue following these developments closely and sharing insights that help you stay ahead, one layer at a time.